Hello, Assalamu alaikum, dear students. Welcome to all of you in CompTIA A Plus lecture number 8, and I am your instructor, Ahmed Malik. From this lecture, we are going to start the next chapter of our this course. As you know that it's a detailed course, and we have divided this course into multiple chapters. Normally, in our 3 to 4 lectures, we try to cover a single chapter. In the same way, this chapter will also be covered in 3 to 4 lectures. So let's take a start. The objectives of this chapter are describe post, BIOS, CMOS, and UEFI, configure the computer firmware, describe watt and voltage, explain power fluctuation and devices that protect against damage caused by the power fluctuations, explain CPU architecture, describe RAID, describe common ports, cables, and connectors, describe monitor characteristics, select appropriate components to upgrade a computer system, select components for specialized computers, and also explain safe disposal methods. Post. When a computer is booted, the basic input or output system BIOS performs a hardware check on the main components of the computer. This check is called a power on self-test or post. Through this step, small amount of power or electricity is sent to all the parts of your computer system to check either they are working properly or not. If a device is malfunctioning, an error or a beep code alerts the technician of the problem. BIOS manufacturers use different codes to indicate different hardware problems. Different types of beeps are shown in the figure, but these can be different on different motherboards. Motherboard manufacturers may use different beep codes. Always consult the motherboard documentations to get the beep codes for your computer system. I am here going to share a very useful tip to check the post operations. To determine if the post is working properly, remove all the RAM modules from the computer system and power it on. The computer should emit the beep code for a computer with no RAM installed. This will not harm the computer system. BIOS, basic input output system. All motherboards need a BIOS chip. BIOS is a read-only memory chip on the motherboard that contains a small program, also known as less lines of code, that controls the communication between the operating system and the hardware. Along with post, BIOS also identifies which drives are available in your system, which drives are bootable, how the memory is configured and when it can be used, how PCIe and old PCI expansion slots are configured, how SATA and USB ports are configured, motherboard power management feature, and many small features are controlled by your BIOS system. CMOS. The motherboard manufacturers save the motherboard BIOS setting in a complementary metal oxide semiconductor CMOS memory chip. When a computer boots, the BIOS software reads the configured settings stored in CMOS to determine how to configure the hardware. The BIOS settings are retained by CMOS using a battery. If the battery fails, important settings can be lost. Here is a useful tip to check either your CMOS is working well or not. If the computer's time and date are incorrect, it could indicate that the CMOS battery is bad or is getting very low. The old type of BIOS or read-only memory has been replaced with UEFI. Most computers today run Unified Extensible Firmware Interface UEFI. Our new computers come with UEFI, which provides additional features and addresses most security issues with legacy BIOS or old type of ROM memory. UEFI can run on both 32 and 64-bit systems. It supports large boot drives and includes additional features such as Secure Boot. Secure Boot ensures your computer boots to your specified operating system. This helps to prevent rootkit from taking over the system. Let's have a small video demonstration to understand the new type of BIOS UEFI.
Have you ever heard about a Unified Extensible Firmware Interface? Maybe not, but I bet you have heard of a UEFI BIOS. Well, UEFI stands for Unified Extensible Firmware Interface. We're going to kick it off here, investigate the UEFI BIOS. I'll do the investigating, and you'll get the tour. Let's begin. So, my computer here has just booted into the UEFI BIOS. Every computer is a little bit different, and may require different keystrokes in order to access the BIOS. For example, my computer required me to press the delete key after I first turned it on. So here we are. This is a real BIOS, not a simulated BIOS. In the top left corner, you can see my motherboard's model number, awesome, and my CPU temperature. Right below that, you can see my motherboard temperature. In the middle here, we can actually see our system time and date. Right below that, we can see the current firmware of my UEFI BIOS. What I really enjoy, though, is in the top right corner of the screen where you see these listed items here in the top. Here you can view my current CPU, which has 4 CPU cores and 6 GPU cores. You can view the operating frequency for both my CPU and my RAM. You can also see the total size of the RAM that I have installed in my system. Now remember, this is the UEFI BIOS. What that means is I have a graphical user interface that includes keyboard and mouse support. This is very different from what we've seen with legacy BIOS. To further demonstrate this, look at this horizontal bar right below my system time and date and my CPU and RAM. From left to right, this is my boot order of my computer. What's even more awesome is the fact that I can drag and drop these items anywhere. We will focus on configuration of this in another video. So let's take a quick look at the UEFI BIOS. Let's start by investigating the left side of the screen. Here we will find that we have an area for motherboard settings, overclocking our system faster performance, and an area called Flash, which allows us to flash our system with an updated UEFI BIOS. Now on the right side of the screen, we have a section where we can choose different overclocking profiles. We can pre-build these for the right game or video editing occasion. Down below that, we have a hardware monitor where we can check out the power use and cooling. We can even have customized fan speeds and even view graphs here. And lastly, we can visit the Board Explorer. The Board Explorer is awesome because this allows us to have a beautiful and interactive view of what's actually attached to our motherboard. So it's time for the deeper look. So first, we'll head over to Settings. In Settings, we look at System Settings, which I can either click on with a mouse or click the Enter key. And inside of here, we see time and date, as well as in text, what's connected to my motherboard and the firmware version. We next have the Advanced area. In the Advanced area, we can do a lot of fine-tuning and control of both the peripherals and the power settings of our motherboard. Another item we can customize is going to the boot settings. So I'll head back out and go to boot. This is extremely important. This allows us to customize the boot order of our system, both using device preference and security settings known as Secure Boot. We'll take a look at that later on. If we go into the security settings, though, we can take a look here and see that we have the ability to set an administrator password. This will prevent other people from accessing and modifying our UEFI BIOS settings. Now let's get out of this settings area, and let's go all the way over and see overclock. We'll take a look at the overclock settings, and you can see all the customizations possible here. This allows you to fine-tune your machine for the performance that you desire. This may cause some extra wear and tear in your system due to increased heat. Next, we will have the M-Flash section. This is where you can utilize tools in order to flash your UEFI BIOS with the latest firmware. This is commonly done with a USB key or flash drive plugged in. Not too much. Heading to the right side, we'll go over to our overclocking profiles. This is where we can pick what overclocking profile to use that we have pre-built and saved for a given situation. This should be good for gaming or video editing, or maybe even normal computing use. Last two sections. We'll take a trip to the hardware monitor. Here we can look at the CPU fan speed, temperature, as well as case fan speeds. Some UEFI will even allow you to set an average temperature you'd like your system to stay at, and your cooling fans will react accordingly to do their best to keep your system as close to that target temperature as possible. Love it. We'll back up and take a look at that Board Explorer. I click on the Board Explorer. This is great. In the Board Explorer, you can get a graphical view of your motherboard. The highlighted sections allow you to hover your mouse over them and read a description of what is connected to that component. For example, if I were to take my mouse cursor and I can hover over the RAM slot where my memory is, I can actually see information regarding it. You can see that each RAM slot has a 4 gig memory chip installed. Also, if I hover over my SATA ports, we'll get information on what is connected to that individual SATA port. You can see that I have 2 SATA devices attached. One of these is my device here, and the other one is Blu-ray disc DVD ROM drive. This is a great UI tool to visually see how the motherboard is arranged and what is connected to your machine without even opening the case. So if you have time to take, get into your BIOS and view your settings and learn how your device is connected and running.
BIOS and UEFI security. The legacy BIOS or old type of ROM support some security features to protect the BIOS setting. However, the latest one, UEFI, adds some additional security features. Some common security features found in BIOS or UEFI systems are includes passwords, drive encryption, LoJack, TPM, and secure boot. Passwords allow for different levels of access to the BIOS settings. We can set a password to secure our BIOS settings. Drive encryption. A hard drive can be encrypted to protect data from theft. LoJack. It is a very common and very useful feature. Most of the people are not aware about this. This is a security feature that allows the owner to locate your device in case of device theft. He can also lock and delete the device, can remove all the data in case of theft. Trusted Platform Module TPM is a chip designed to secure hardware by storing encryption keys, digital certificates, passwords, and data. Secure boot is a UEFI security standard that ensures that a computer only boots as operating system that is trusted by the motherboard manufacturer. Firmware update. Motherboard manufacturers may publish updated versions of BIOS to provide enhancement to system stability, compatibility, and performance. Early computer BIOS information was contained in ROM or read-only memory chips. To upgrade the BIOS information, the ROM chip had to be physically replaced. We cannot upgrade softwarely. Modern BIOS chip or UEFI are electrically erasable, programmable, read-only memory EEP ROM, which can be upgraded by the user without opening the computer system case. This is called flashing, or this process is called flashing the BIOS. To download a new version of BIOS, Consult the computer's manufacturer's website and follow the recommended installation process. But keep in mind that it is a sensitive process and can be harmful if you face any power failure during this process. So let's have a small video demonstration to understand the basic configuration of your latest BIOS or UEFI.
Hello there, we are back in the UEFI BIOS, and this time we're here to change some settings. In this video we get to configure the UEFI BIOS, and we are going to explore the following items. We will set up our boot options, customize our security settings, take part in some interface configurations, and even use the firmware backup and update tool. So let's begin. We want to configure our boot options. Now you'd think jump straight into motherboard settings and hit boot, but technically we don't even have to go there. On the main UI BIOS screen, I can quickly and easily see my boot order listed in this horizontal toolbar. Now this is awesome because if I want my optical drive to be given more preference than something else, I can just click and drag that optical drive to the front of the list. Now it's being given the first boot order preference, such as the optical drive would be booted from before the hard disk drive or USB or anything else. This is great. Now this feature does depend on your motherboard and UEFI firmware, so let's take a look at the official method as well. We'll go in settings, and then I can go ahead and click on boot. And inside of here we'll see this massive list. Now before we just dive into this list, I'd like to take note of the boot mode select. With boot mode select here, I see that the default option is Legacy and UEFI. It has been predicted that in the next couple of years, Legacy will no longer exist. It is here at this time to allow our board to be backward compatible with devices that require Legacy BIOS settings. If you'd like to, you can select the option and you'd actually be able to click UEFI only, as long as you know your devices will still be supported. Let's continue. So down below is my list. My current boot option 1 is set as my optical drive, the UEFI CD DVD. That's from my previous drag and drop maneuver. To modify this list, you can just click on any one of these items, such as, for example, boot option 1, and I can choose what device will be booted first. For example, how about my USB key? There we go. And now that's first. You see that horizontal list from left to right has changed up above. We can also go and click on any one of these items and use plus or minus arrows to move them up or down on the list as well. I personally like the drag and drop option we saw previously. Next, it's time to take a look at some secure settings. Back to motherboard settings and then into security. We can find some important settings we can configure. Here in the security settings, let's take a look at the passwords. The administrator password can be set to prevent other people from accessing and changing your BIOS settings. I'll click enter, and we're going to make this thing, there's already a password on it. It was Cisco, we're going to make it Cisco again. Create new password, Cisco. Confirm new password, Cisco. And now our administrator password is Cisco. If you want to change and save our BIOS, you're going to need that password of Cisco to do it. Now the user password down below, this is special. This can be set to prevent the operating system from loading on your machine until a user has entered the correct user password stored here in BIOS. Further, there's this feature called UKey. UKey feature allows the BIOS administrator to dedicate a password to a specific USB key or flash drive. The USB key or flash drive will be needed to be plugged into your machine when a user wants to access the operating system of the machine. Wow. Never knew a flash drive could be so important. Let's continue on and take a look at some of the interface configuration settings. In the main settings area, we're going to advanced. And inside of advanced, we're going to access the integrated peripherals. Within the integrated peripherals, we're going to find a good amount of settings to control. In this section, we have the ability to control the onboard LAN controller. This is our physical network part of the device. We can actually disable it here if we don't want to use it. We take a look at Wi-Fi Bluetooth controller. We can also control if the Wi-Fi and Bluetooth components are allowed to be used on the computer. Think of this as using software to disable individual hardware components on the physical computer before the operating system even got a chance to use it. This is awesome. We can even make changes to how the SATA hard drives are going to be viewed. For example, I can click enter on SATA mode. We can have these hard drives in the legacy IDE mode, current AHCI mode, or even by utilizing RAID. On top of all that, down below, We can customize the SATA connections are allowed to be hot swappable as well. Let's back up a little bit and take a look at some USB configuration. In Settings, Advanced, USB Configs, we want to take a look here and see that we can actually control both legacy USB support as well as disabling or enabling the USB controller itself. With this coming into mind, I want to imagine this machine being in a high risk or high profile environment, and you have to be the IT professional that's concerned about people bringing in external USB flash drives. Problem identified and problem solved. Let's take a step back. Now what we want to take a look at is Windows configuration. Right here in the Windows configuration, we can control how quickly our machine will boot. We can do this by activating Fast Boot or by activating MSI Fast Boot. These will allow your systems to come online more quickly by skipping some of the more thorough post-verification tests. Next, we want to talk about what makes our machine boot and that's our wake-up event settings. We can click on this item to control what is allowed to wake up our computer and turn it on. There's a couple here, not too many. We have one last section to cover in this video, and go all the way back, and we're going to head over to MFlash. MFlash is all about firmware updates for our UEFI BIOS. We will have the ability to save our current BIOS to a USB flash drive that's plugged in. This will allow us to restore it at a later date. We also have the ability to update the BIOS using this tool. So for example, I can click Save BIOS to Storage. And there is my disk, which I can click on. Leave the default. And it's saving it a USB flash drive. By using the Update BIOS feature, we can load a BIOS file that is on the USB flash drive that is plugged into our machine. Now this is going to be awesome because this is your storing and recovery, especially when you have settings that you're concerned about losing and not having in the future. We can use the Update BIOS feature to actually select a file off of a USB thumb drive. And here, if I had a BIOS ready to go, I can click on the UEFI flash thumb drive and be able to update the BIOS itself. Now, while every UEFI BIOS will be a little bit different, you should have a much better understanding of how to configure some of the important settings within your UEFI BIOS.
Watt and voltage. There are four basic units of electricity used in a computer system, and a computer technician must have small know about these electricity units. Voltage. The measure of work required to move a charge is called voltage, measured in volts. Current. The measure of the amount of electrons moving through a circuit per second is called current, normally measured in amperes. Resistance refers to the options to the flow of current in a circuit is called resistance, measured in ohms. Power. The measure of the work required to move electrons through a circuit multiplied by the number of electrons going through the circuit per second is called power, measured in watts. A basic equation known as Ohm's law expresses how voltage is equal to the current multiplied by the resistance. The formula is V is equal to IR. In an electrical system, power is required to the voltage multiplied by the current. P is equal to VI. Power supply voltage settings. On the backside of some power supplies, there is a small switch called voltage selector switch. This switch sets the input voltage to the power supply to either 110 or 115 or 220 to 230. As in different countries, different standards of voltage are being used. Some countries are using 110 and some countries are using 220. A power supply with this switch is called a dual voltage power supply. But if a power supply does not have this switch, it automatically detects and sets the correct voltage. The current voltage setting is determined by the country where the power supply is being used. Power function types. When the power voltage in a computer system is not accurate or steady, computer components might not operate correctly. The following types of AC power fluctuations can cause data loss or hardware failure. Blackout, complete loss of AC power. Brownout, reduced voltage level of AC power that lasts for a period of time. Noise, interference from generator and lightning. Spike, sudden increase in voltage that lasts for a short period and exceeds 100% of the normal voltage on a line. Power surge, dramatic increase in voltage above the normal flow of electric current. Power protection devices. These devices are used to support and help against power fluctuation problems. Also used to protect the data and computer equipments. Surge protector. It helps to protect against damage from surge and spikes. A surge suppressor diverts extra electrical voltage that is on the line to the ground. UPS, uninterrupted power supply. It helps to protect against potential electrical power problems and provide a consistent quality of power when brownouts and blackouts occur. SPS, standby power supply. It helps to protect against potential electrical power problems by providing a backup battery that is on standby mode during normal operations. This device is not as reliable as a UPS because of the time it takes to switch over to the battery. Cooling mechanisms are very important as our computer works or processor performs some processing, it generates heat. It is very important to keep it cool. There are many different methods to keep our computer system cool. Case fan. A case fan is used to increase the airflow in the computer case and allows more heat to be removed. Some cases have multiple fans with cool air being brought in while another fan is blowing out hot air. CPU heatsink. A heatsink has a large surface area with metal fins in order to draw heat away from CPU and dissipate it into the surrounding air. The thermal compound is also placed between the heatsink and the CPU to increase the efficiency of heat transfer. A CPU heatsink without a fan is known as passive cooling. CPU fan. It is common to install a fan on top or within a heatsink in order to move the heat away from the metal fins. A CPU heatsink with a fan is known as active cooling. Graphic card cooling system. Video adapter cards have a graphics or processing unit known as GPU that generates excessive heat. Water cooling system. A metal plate is placed over the processor and water is pumped over the top to collect the heat the process generates. The water is pumped to a radiator to disperse the heat into the air and then the water is recirculated. That's enough for today. And now finish our this lecture with a beautiful quote. Education is the best friend. An educated person is respected everywhere. Education beats the beauty and the youth. So dear students, thanks for watching this video and stay connected for all the upcoming videos. Thank you very much.